In this video, I want to invite you to think with me about what it means to be a scientist, or what it means to be a researcher. I'm going to be focusing specifically on the behavioral and social sciences, but I think this would also apply to the physical and hard sciences as well. Now, when we think about scientists and their purpose, the first thing that often comes to mind is the discovery of facts, of scientific facts, kind of like explorers going to investigate a new world. Scientists are investigating new phenomena and trying to discover what they are or prove what they are. I want to challenge that notion. Scientists don't discover facts. They may discover material, they may discover phenomena, but facts are outside of the purview of scientists. What I mean is, there is no such thing as a scientific fact. All we get in science is that something has not yet been disproven, or a hypothesis has stood the test of time, and there hasn't yet been an observation that disproved it or challenged it. So when you hear somebody say, it's a fact that, what they're really saying is, this statement has never been disproven, and so it will stand until someone comes along and disproves it. And this, of course, occurs throughout history. Everybody knew that the world was flat, for example, to use an old hackneyed example. So in science, we don't get facts, we get hypotheses that stand, or hypotheses that have not yet been disproven. To take a famous example, we have the gravitational constant, or the law of gravity, which says that objects will gravitate towards one another based on their mass. So the greater the mass, the greater the pull that object has on other objects. Now, this hypothesis began in the 17th century with Galileo, who hypothesized a single gravitational constant, that the Earth pulled on all objects equally, and he tested that and was unable to disprove it, and so it stood. And it stood, and it stood, and it stood. So we have hundreds of years that the gravitational constant hypothesis has not been disproven, and so that's about as good as we can get when it comes to identifying laws. So we call that the law of gravity. Newton, who closely followed Galileo, had his laws of motion, but he interestingly couldn't predict why an object, or why movement began, or motion began in the first place, so he had to posit God. So then, what does that mean for everything that we know about human experience, about depression and anxiety and relationships and growing and learning and so forth? What we get in science, the best we can do is hypotheses about why people behave the way that they do, or what sort of factors can predict certain behaviors, or predict the absence of certain behaviors. And if you watch the history of psychology or the history of sociology, we will see hypotheses that are very popular for a period, and everyone is doing research, and even lay people who read magazines and read books and watch television, they're getting exposed to these ideas, and it's taken as, oh, this is state-of-the-art science. Well, what that means isn't brand new discoveries. It generally means new hypotheses that are exciting, and perhaps they have displaced old hypotheses. So we see the evolution of understanding, evolution of hypotheses about why people do what they do. So I've used a couple of words, and I want to make sure you understand what they mean. A hypothesis, if you remember from 6th or 7th grade science class, is a guess that is based on evidence. The evidence might be a series of experiences that you've had. It might be common knowledge. It might be something that you read about in a book, but you might get an insight based on reading something and think, well, if that happened, then I wonder if. It's not just random guess or prediction. The prediction is usually based on previous experience. And so a hypothesis already requires that the scientist or researcher has done a little bit of work. And the better the hypothesis, or rather the more research that has gone into the hypothesis, the better the hypothesis will be. And then when a hypothesis is tested, even if the prediction isn't 100% accurate, that doesn't mean the hypothesis gets thrown away. It just might mean that there are more variables, there are more factors at play in order to completely understand the phenomenon. And so I'm talking generally here, so let me give you an example. It's fairly common knowledge, again, this isn't a scientific fact because scientists don't work in facts, they work in observables and rational statements and logic and things like that. But it's pretty common knowledge that depression is something that humans can experience. And depression has been defined a number of ways by the American Psychiatric Association. But we tend to think that humans can identify when they're depressed to a certain degree, and then it has to be confirmed by psychiatrists who really understand it, or so we're led to believe. But depression is something that we understand humans can recognize in themselves and sometimes in others, enough to be able to say, I think you're depressed. Well, upon what is that observation being based? We could then ask. And so there's this collection of observations that are defined as depression. Is there such thing? Is there a reality of depression? Well, we don't really know what exactly it is, so we can't say that we've discovered depression. We have just heard so much about it from so many people that there must be something to it. Because we can't find depression in the brain, and trust me, hundreds of scientists and neuroscientists are looking for it, hundreds, thousands, tens of thousands. It's a very popular subject in neuroscience right now. Until we have some neurological correlate, about which I'm a little doubtful, but until we have that, we have to take somebody's word for it, that they understand or they recognize their symptoms, and they're capable of reporting on those symptoms. But to say that a person is, without doubt, or has depression, that's not the same thing as being able to recognize whether an object has mass, which can be like directly measured and tested against other things. So if you say that you think you have depression, what is it that you actually are in possession of? And this brings us to another concept or set of concepts in the philosophy of science, and that is the difference between subjectivity and objectivity. Subjectivity and objectivity. These are familiar terms to the young science student. You've probably heard a subjective opinion versus an objective fact. Something that is objective is measurable, it is observable. There's been some sort of systematic approach to the measurement and observation, and it exists in reality. And so it takes up space, it has duration. These are the parameters that were defined by Galileo and Newton those hundreds of years ago, upon which modern science has been based. And so objectivity meant something very different between the modern era. So ever since the 17th century, objectivity tends to mean exists in reality. And so it exists under the sun. There is an actual object or thing that's taking up space right now that's there. Therefore, it is real, it is objective. Subjectivity, by comparison, is only, or can only be experienced. So for example, yesterday my office was cold. It felt cold to me. I didn't actually take a measurement with a thermometer, but my skin had goosebumps, I needed to put a jacket on, I had a space heater running. All of these things were my opinion about the temperature. Now I could say it feels cold to me, that's a subjective perception, or I could say it is cold, which would be an objective statement, but it would have to be based on some sort of systematic observation or empirical data gathering in comparison to other bits of data. And so if I were to bring a thermometer in here and see that it was 50 degrees, well, would that mean that it's cold? Well, we would need a baseline. So what's a baseline? Well, a comfortable office is probably somewhere in the 70s, high 60s, maybe low 70s, something like that. And so 50 would be below that, therefore it's cold. That would be an objective statement. The I feel cold, that's a subjective statement. And so in science, we have both. And often in psychology in particular, and sometimes sociology and criminal justice, we have a subjective experience that we're trying to understand using the tools of objectivity or modern science, following Galileo and Newton's guidelines all those years ago. So with depression, this is a subjective experience or a subjective awareness of my own experience. But how can we talk about that objectively? Well, we would need to do some sort of systematic observation, collect cells, look at neurons, give somebody electroconvulsive therapy to see if it's something that's happening in the cortex, cerebral cortex, give somebody a drug and see if it changes the symptoms of depression, changes their experience. How can we understand this relationship between a body that is in space and has duration and time? You can see me even through this video, and you can't pass through me, right? I'm actually taking up space. I have mass. I'm real. You can see that, but you can't see my experiences. You suspect that I have them, and that's the subjective part of my being, and the objective part is the material body that you're seeing in front of you. So psychologists and behavioral scientists are limited to a large extent on subjective properties that they try to use the tools of modern science, which require objectivity and systematic empiricism. And so you're seeing a big gap right there. And right now it's a really popular gap to explore. Where does the mind connect with the body? Where does the body connect with the mind? And that's a philosophical question. It's a neurological question, it's a psychological question, it's a religious question, right? These are things that we've looked at for a long time. But I've looked already with you at at subjectivity and objectivity, as well as the idea that facts are not something, they are not the commerce of science. Scientists do not work with or deal in facts, they deal in observations and hypotheses that either stand or are rejected.